We will end this lecture by discussing orderings among the various broadcast abstraction that we have studied. First, let us look again at causal order broadcast. And we have two processes, P1 and P2. P1 broadcasts the message. It increases its local vector timestamp and delivers M1 locally. P2 broadcasts a message, and in this case it broadcasts M2 and delivers M2 locally, which is possible. Nothing wrong with that. Now, P1 delivers M2, and that is fine because the vector timestamp of the message is less than the vector timestamp of the process. And the same thing happens at P2. So now we have a situation where at P1 it first delivers M1 and then M2, and at P2 it delivers M2 and then M1. So is something wrong with that? So as you notice, the delivery order isn't the same. So what's wrong? And actually there is nothing wrong, because these two messages that has been broadcast, M1 and M2, have no causality among them, and therefore they could be delivered in any order at different processes. So causal order broadcast does not mean that all messages will be delivered in the same order. There is other orders. We have seen the specification of single source FIFO order. We have seen causal order, but there is also another order which is called total order broadcast. We will come to it soon. First, let us remember the single source FIFO order, which in this case messages from the same process are delivered in the order sent, or the sent order. And it says here that for all messages M1 and M2 and all processes PI and PJ, if PI broadcasts M1 before M2, and if PJ delivers M2, then PJ delivers M1 before M2. We have seen that before, and you can see very clearly from this formulation that we do not require the delivery of post messages. We have discussed this issue before. Now let us go to total order. And intuitively, total order says everyone delivers everything in exactly the same order. The same order, that's all. So for all messages M1 and M2, and for all processes PI and PJ, if PI and PJ deliver both messages, then they are delivered in the same order. Again, remember that we said that this formulation does not require delivery of both messages. And another important issue here is that notice that everyone delivers in the same order, but this might not be the send order or even the causal order. We are going to discuss total order broadcast quite late in this part 1 of the course, but it will be discussed even more in part 2. So as you can see, total order is not comparable in any sense to single source FIFO order or causal order. So let us just practice these examples and see which broadcast order we are talking about. So here is the situation. We have different messages. Let us call this M1. This is broadcast with the broadcast event A. And here's M1. And the broadcast event B broadcasts a message called M2. So, is this a single FIFO order? That's the question now. This is a single FIFO order. And the answer, yes, because each process only sends a single message. So this is a single FIFO order. Now, is this a total order then? And the answer is definitely no, because at the first process, P1, we deliver M1 and then M2, whereas in the second process, we deliver M2 and then M1. So is this a causal order? And the answer is yes, because there is no causality between these two messages, so they can be delivered at any order, it's fine. That is the first example. Let us take another example here. So here's an example again. We have P1, we have P2, we have M1 here, and we have M2 here. So this is a FIFO order, and the answer is of course no. They are not a FIFO order because these two messages are sent from the same process P1, but they are delivered in a different order by the two processes. So this is a total order then. And the answer is yes. M2 is delivered before M1 on both processes. And this is a causal order? The answer is of course no, because in a causal order, M1 has to be delivered before M2 at all processes, but that is not the case. So now let us take one more example. Here again, we have the two processes P1 and P2, and here we have the message M1 here and M2 is here. So is this a single source FIFO? Again, yes, it is, because each process sends only one message. This is a total order. The answer is no, because messages are delivered on different order on two different processes. Now, is this causally ordered delivery? And the answer is no. So what do we have here? We have a single source FIFO that is not a causal order, and it is not a total order. This gave us, in fact, some kind of hierarchy of ordering of broadcasts, where the stronger broadcast primitive implies the weaker broadcast primitive, or the weaker broadcast abstraction. And in this picture, you don't have the total order broadcast, because total order is not comparable with the others. So let us just start from this picture and try to understand it. So if we have a uniform causal order broadcast, then it satisfies all the properties of reliable causal order broadcast, and it also satisfies all the properties of causal best effort broadcast. And it also here, this is stronger than everyone here. So this one is stronger than everyone here. Reliable broadcast implies reliable FIFO, and implies reliable broadcast. Uniform reliable broadcast implies uniform reliable FIFO, which implies uniform reliable broadcast. And again, causal order best effort or reliable FIFO implies both imply FIFO best effort, and FIFO best effort implies best effort broadcast. This gives us a total picture of all the different orderings among the broadcast algorithm that we discussed in this lecture.